think I'm losing my marbles. Anyway, so we talked about molten material, where it comes from, where it's melted from, whether it cools below ground, above ground. All of those give it its different characteristics, chemical composition and color, felsic, intermediate, mafic. The texture based on where it cools and how fast it cools. But also that different material, because it is different chemically, it can give us different volcanoes as well. So we talked about some hazards that we would encounter with volcanic activity. So let's kind of put those to volcanoes, the different types of volcanoes. Shall we? So before we do, let me give you another part of the super secret code. It is the number 9. The number 9. You got me? The number 9. So this is kind of a longer section. We'll split it up into a couple of different videos. So there are 3 types of common volcanoes we'll talk about, 1 uncommon type, so there'll be 4 we'll talk about. So the common types of volcanoes we'll talk about in here: cinder cone volcanoes, composite volcanoes, sometimes known as stratovolcanoes, and shield volcanoes. Now the 4th one we'll talk about is very uncommon, thankfully, and those are super volcanoes. So looking at the 3 common types, cinder cone, composite, or shield, I know these cartoons kind of look similar, but look at some of the measurements. Cinder cones, about 1.5 kilometers in diameter, about 300 meters tall, so maybe about 1,000 feet tall or so. Composite volcanoes, 15 kilometers wide, so it's about 10 miles, 3 kilometers high, it's a little over 1 mile high. And look at shield volcanoes. They look less steep, and they are. These 2 are very steep. Shield volcanoes less steep, but they can be 120 to 150 kilometers wide. So we're pushing 100 miles wide. And then 9 kilometers in height. So about 5-6 miles in height. So there are shape differences as well. But that actually goes back to the material, the molten material, the magma that erupts as lava to create these. Different chemical compositions will give these different shapes and also different hazards associated with these volcanoes. So the simplest type of volcano is called a cinder cone volcano. Small blobs of lava called cinders are ejected from a volcanic vent. The lava is blown kind of violently into the air, cools quickly, and then all these little pieces kind of rain down around the vent and build up this cone called a cinder cone. It's made of cinders, a lot of loose material, so they're actually pretty hard to kind of climb up. Again, they rarely grow bigger than about 1,000 feet or so. You can also have some lava flow events as the eruption in these things are kind of dying. But, they can be of decent size. Scoria and or basalt is very, very common here. So again, it looks like a bunch of small pieces, blobs, kind of being shot out of these vents. It's kind of like it's kind of like the shart of the geologic world. Stick with me now. A shart is a poop fart. All right. When you pass gas, but then when something a little extra comes out. Stick with me. Same thing here. All right. There's a lot of gas, so that's why you're getting a lot of this stuff being shot out like a fountain. So you're getting a lot of this gas-rich material, small blobs, cooling very quickly. Since there's a lot of gas behind this, in these small cinders, a lot of air holes, very vesicular in nature. Scoria is a vesicular, extrusive igneous rock. And then as that's kind of dying, dying down, then there might be a lava flow at the end, kind of like a shart. You kind of get, that initial gassy blobs, and then you might have a little just diarrhea kind of squirt out at the end. I'm not trying to be gross. I'm just trying to give you an analogy that, I don't know, it makes sense to me. So anyway, cinder cones are like the sharts of the geology world. So here are those kind of blobs of, small little blobs of material. You can still see they're kind of red hot, but they cool actually rather quickly. And as they hit the ground, there's the black material called cinders, very, very loose material, red, sometimes kind of a rusted red color, black, very mafic in composition. Some examples include Lassen Volcanic National Park in California, kind of on the flank of Mount Edziza in British Columbia, Canada. Oftentimes you find these around bigger volcanoes, but you can see this very stereotypical cone shape, that black color indicative of the cinders that make up these cinder cone volcanoes. Again, here's that very cone shape, very cartoonish cone shape. You know, if you told a kid to draw a volcano, this is kind of what they would look like. But again, maybe 1,000 feet tall. Looks like you can see some structures here, you know, compared to these trees. So they are pretty, if you're trying to climb up one, which there are plenty you can, it's kind of hard because the material is very loose. So here's a video I want you to watch on a cinder cone eruption down in Mexico. Paracutin is a cinder cone that erupted in the middle of the last century, and you know it built up actually very quickly. Cinder cones can go from nothing to an eruption and having a cone within weeks, so they can build up very quickly. And here's a video of one of those happening in Mexico. All right, so those are cinder cones. Then we have composite volcanoes. Composite volcanoes make up some of the world's most memorable and beautiful mountains. Mount Rainier in Washington, Mount Fuji in Japan, the San Francisco peaks up in Flagstaff, all composite volcanoes. Mount St. Helens, famous eruption in 1980, composite volcano. They have kind of steep sides like cinder cones do as well, but these can grow to be many thousands of meters tall, many, you know, up to, you know, a couple miles high. And this is much bigger than a 1,000-foot high cinder cone. Hazards associated with this are many. Pyroclastic flows, lahars, and ash, all common. And these tend to, when they erupt, they explode pretty violently. Think Mount St. Helens. Cinder cones, a lot of gas, a lot of, you know, a good light show, a lot of kind of little pieces of lava kind of just being shot out, and then maybe a little lava flow at the end, but nothing too catastrophic. These go boom. Andesite is the common rock, an intermediate extrusive igneous rock that makes up these volcanoes, and it is the most dangerous common type of volcano. Supervolcanoes are by far the most dangerous. If those were to go off, it could be the end of the world, but they're just so rare. More on that in a little bit. But as far as common types of volcanoes, these are the ones that tend to cause the most damage, the most deaths. It's called a composite because it's kind of made up of altering layers. Over time, as these erupt, they're made up of altering layers of lava flows and pyroclastic material, ash and stuff, and pyroclastic flows, ash and other material that kind of settled on. So you get a lava flow and then ash on top, and lava flow and ash on top. So it erupts, you got your lava flow, it cools, and the ash falls and settles on top. So that's why they're called composite. They have these layers to it. Oh, and here you go. But yeah, so some of the most memorable mountains are these types of volcanoes. Mount Rainier in Washington, Mount Rainier National Park. If you've never been, it's one of my favorite places on earth. Had the chance to climb up Mount Rainier. But in the back of my mind the whole time, I'm like, wait a minute. This is a volcano. This is a volcano. Mount Fuji in Japan. Look at that. Gorgeous. Mount St. Helens in Washington, before and after the eruption in 1980. These go boom. These go boom. There's not a ton of like lava flows like we would think of, you know, in Hawaii with those types of volcanoes. More on that in the next video. But these kind of tend to be more explosive, more ash, more pyroclastic flows. You do get some lava material, but not what you would think of. These are just more explosive. A lot of pressure behind these because they're made up of andesite, and andesite being an intermediate igneous rock. That material coming from kind of between the crust and the upper mantle is a much more sticky, higher viscosity material. So as it moves kind of slowly, and it can kind of get stuck, it can get stuck, and you start to build up a lot of pressure behind this andesite, which is a little bit more sticky than, for instance, like a basalt, a runny basalt. And so you get this pressure built up until eventually cinder cones, scoria, basalt, make kind of the same mafic material, a little bit further down, lower viscosity, very runny, so you're not getting big explosions. So that's why you're getting lava material kind of more flowing out, more gentle. Yeah, composite volcanoes, they go boom. again, kind of a before and after, just to show you the whole top of the mountain just gone. Please watch these videos on Mount St. Helens. All right, their material from these videos may be assessed, so make sure you're watching this video and additional video on, in general, how dangerous are the volcanoes in the northwest of the U.S. That's kind of where most of our bigger volcanoes, kind of California, Oregon, Washington. So another video as well. When you go to this page, the video is kind of right at the top of the screen there. So let's go ahead and pause there. So we talked about cinder cones and composite volcanoes. We'll stop here for this section. When we come back, we'll talk about shield volcanoes and supervolcanoes. I'll see you back here in just a minute.